All right, today we are going to be looking at some vocabulary words. We are going to be studying relations, and we are trying to figure out whether a relation meets a special category to turn it into a function. So think of relations as the big group, and then functions pass this special test, and that allows the relation to be categorized as a function. Sort of think it like you've got your big group of friends, and then some of your friends pass these magical tests you have to make them become your best friend. So it's that same idea. So first, let's just figure out what is a relation. So a relation is just a set of ordered pairs that shows how two things are connected or associated. So again, ordered pairs. And there are some different ways that we can show relations. So relations can be shown as just a set of ordered pairs. Relations can be shown as a set of ordered pairs organized in a table. Relations can be a set of ordered pairs that have been graphed on a graph. And then relations can be a set of ordered pairs that have been represented in a mapping diagram. And that's probably the one that you're the least familiar with. So how to read a mapping diagram. So I just follow 2 to 0, and that means I have a point at 2, 0. And then I would say, okay, -5 goes to 2. So I have a point at -5, 2. And -5 goes to 4. So I have a point at -5, 4. And then 0 goes to -1. So I have a point at 0, -1. And 3 gets mapped to 4. So I have a point at 3, 4. And then 1 gets mapped to 0, so I have a point at 1, 0. And 1 gets mapped to 5, so I have a point at 1, 5. So again, there are my set of ordered pairs, and that's how you read a mapping diagram. Okay, so then relations can be either discrete or they can be continuous. So first, let's just read what that means, and then I will help you see it. So discrete is just quantities that can be distinctly counted or separated. Think of them as distinct points. Whereas continuous means the values can change smoothly over an interval. They would be connected points. So if I were to look over here at this graph, this would be an example of a discrete graph because it's distinct points. But if I were to come in and I were to connect those points, now this has turned into a continuous graph because the points have been connected. So that's kind of visually what is the difference between discrete and continuous. All right, then we have one more vocab word, which is function. And a function is just a relationship between a set of input and outputs. So there's your ordered pair, X, Y. However, what makes it special, what makes it become no longer just called a relation, but also go into that category of this relation is a function, is that each input has been associated with exactly one output. And so what does that mean? And the easiest way to kind of visualize this is if I were to look over here, 2 and 0 and 3 are meeting the definition of that input is paired with exactly one output value. However, as soon as you consider -5 or 1, those inputs have now been partnered up with more than one output value, and that would make this problem not pass the function test. So this would be an example of a relation but not of a function. So hopefully that kind of takes that math definition and gives it some context. So now we're going to go into our foldable and we're going to start applying these 4 words. Okay, so I am looking through my set of points and I see that each input in this set of ordered pairs is unique. So none of my input values are repeating, which means I know that this is going to pass the function test. If I go to example 2, I notice that 5 repeats. And I see that 5 has been paired with 1 here, but 5 has been paired with a different number, 7. So right there, this relation no longer meets the criteria to make it a function. So it's not a function, it is only a relation. And then we're going to go to example 3. And I again notice that each of my input values is unique. So this is going to automatically qualify as a function. It's also a relation, but it meets the special category of function. Okay, what if they give it to me as a table of values? Well, right here, I notice I have the exact same input value. But I also notice that -2 has been partnered with -2, and then -2 has again been partnered with -2. So this does still meet the function test. Whereas if I come over here, I see that 1 shows up more than once, my input. One time it's been partnered with -4. The next time it's been partnered with -2. So now this is no longer passing the function test. It's not a function, it's only a relation. Okay, what if they gave it to me as a set ordered pairs in a mapping diagram? Well, again, my focus is right over here, the input bubble. And so if I look, -2 has 1 arrow coming out of it. My next one, 0 has 1 arrow coming out of it. 1 has 1 arrow coming out of it. And 2 has 1 arrow coming out of it. So each input has been paired with exactly 1 output. So this is meeting the function test. So this relation is a function. If I were to go look at example 7, right here, I'm focused in on the x's, but I notice that -1 is partnered with +1, but then it's also mapped to +3. So that 1 input value has been mapped to 2 different output values. So this is no longer a function. This is a relation only, not a function. Okay, so then what if it's given to me as a graph? Well, if it's given to me as a graph, there is this thing called the vertical line test that makes it very easy to quickly see whether something is a relation only, or if the relation meets the category to make it a function. So the vertical line test is just a visual method that we can use to determine if a graph represents a function. It works by us checking if any vertical line is drawn on the graph. As long as it intersects the relation only 1 time, it passes, it is a function. But the second it touches more than 1 time, the graph touches my vertical line more than 1 time, then it has failed the vertical line test and it is not a function. Okay, so what exactly does this look like? So I always tell kids you can honestly just lay your pencil down on the graph, and if the graph hits the pencil more than once, it has just failed the vertical line test. I am going to sketch in us laying our pencil on the graph and kind of just rolling it. And each time I can quickly see that it only touches the vertical line and the graph only intersect once. So this relation has passed the vertical line test, so it is also a function. And I can also use my new vocabulary words, and I see that all of my points have been connected, so this is a continuous graph. All right, let's look at the next one. I am going to come through and lay down my pencil. And as soon as I lay down my pencil right there, I would quickly realize, hey, this is intersecting my vertical line more than once. It has intersected it twice. So now I know that this is just a relation. It failed the vertical line test, so not a function. This graph is just distinct points, so it is a discrete graph. All right, let's go to example 10. So again, I am going to sketch in my vertical lines. And each time I move my vertical line, it still is only intersecting my relation once. So this is not only a relation, it has passed the vertical line test, it is a function. And this graph is distinct data points, so it is discrete. Okay, again, let's check our last one. Touches once. But as soon as I move it right here, I quickly realize this has now failed the vertical line test. So this is a relation only. And then my graph, the data points are connected, so it is continuous. All right. Hopefully that helped you to really make some connections to what do these 4 vocabulary words mean, what makes something discrete versus what makes a relation continuous, and then also really conceptualizing what makes a relation pass and become a function. Like, what is that distinguishing thing that says, okay, this is no longer just relation, now it is a function. And that was really what we were focused on with this lesson. And that's the end of the lesson.